Hello, good morning. Good morning to you all. We'll be starting the conference shortly. Kindly please start to be seated. Thank you. Good morning, all. We'll be beginning our program shortly. We're waiting for some more guests. And once, probably another 5 minutes or so, we will be starting it soon. Good morning, everybody. Good morning, everybody. Wish you all a very happy new year. I hope the 2022 has been a great year for you all. This is the first VLSI conference being held after 2 years in person post-pandemic. Nonetheless, I request you all to please take precautions, wear your masks. I'm Rama Chaganti, Senior Manager at AMD, responsible for IP Solutions, and I'll be your host for today, this morning. It's with great pleasure I welcome you all to the inauguration of the 36th edition of VLSI Design Conference and the 22nd edition of Embedded Systems Conference being held here in the city of Pearls, Hyderabad. For those of you who don't know, Hyderabad is very famous for its pearls. I'm wearing one. It's chai, biryanis, the weaves, and not just there. It's the IT hub and the pharma capital and growing very strong in other sectors in aerospace, automotive, VLSI, and many more. We are proud to host the VLSI Design Conference here in our city, Hyderabad. During this 5-day conference, we are joined by eminent speakers, academia, and industry veterans, where we will be discussing and learning how semiconductors disrupt semiconductors are driving disruptive innovations in global digitations. So we will be inviting a few dignitaries on the stage now for the lamp lighting ceremony. Due to bad weather in Delhi, Honorable Union Minister of State, Ministry of Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India, Shri Rajiv Chandrasekhar, will join us remotely. May I now request the Principal Secretary for Information Technology, Industries and Commerce of Government of Telangana, Shri Jayesh Ranjan, to join us on the stage. I would like to invite the President of AMD, Mr. Victor Peng, to join us on the stage. I request the Executive Chair of VLSI Design Conference and the VP of Engineering Qualcomm, Shri Shashi Reddy, to join us on the stage. May I now request the Executive Chair of VLSI Design Conference and the Country Head of AMD India, Srimati Jaya Jagdish, to join us on the stage. I request the General Chair of VLSI Design Conference and CEO and MD of MOS-Chip, Sri Venkata Simhadri, to join us on the stage. I request the Steering Committee, VLSI Society of India, Founder and CEO of EPIC Foundation, Dr. Satya Gupta, to please join us on the stage. We will now begin with the lamp lighting ceremony. As light symbolizes knowledge, prosperity, and is the harbinger of positivity, I request the dignitaries on the stage to please do the honors. Wow, that's a beautiful, auspicious start. We thank all the dignitaries for lighting the lamp and officially inaugurating the 36th edition of VLSI Design Conference. I request our guests to kindly be seated. I'd now like to request Dr. Satya Gupta, President of VLSI Society of India and CEO and founder of EPIC Foundation, to deliver welcome address.
Good morning, Hyderabad. On behalf of all of us, because VLSI Society is not just a few of us, it is all of us which has made this organization contribute heavily towards the semiconductor development in the country. So, on behalf of all of us, I would like to welcome all the dignitaries in the state, Victor, Jayesh, Shashi, Jaya, Venkata, all close friends, and all of you to this beautiful city of Hyderabad. As the lady from the AMD said that it's almost 3 years since we are meeting in person. And what a bang we are starting with. So kudos to all the people who joining us today. Probably this is the largest gathering in last basically 7 to 10 years I have seen at the VLSI conference. So thank you everybody. Clap for everybody. So as you know, and this is the 36th edition of the VLSI conference and 22nd edition of the Embedded conference. We do it together. So this whole journey started in 1985 when few of the leaders at that time, Dr. Prabhakaran and Vishwani and few got together and started this organization called VLSI Society of India. The first conference was held as a symposium in 1985. And for good fortune, I was a young student at that time, and I had a good fortune to have a paper in the first conference in 1985. So, been associated with the conference since then. So, a small gathering of about 85 people in the last basically 40 odd years has grown to a juggernaut and has become one of the largest platform in the world for the semiconductor and VLSI design, not just in India, I think VLSI Design Conference is almost becoming the second largest conference after DEC. So thanks for all of you to make it basically happen. So big applause for all the people. While we did not meet in the person, a lot has happened in the semiconductor industry, globally and in India. All of you know that globally there has been a very significant acknowledgement that what semiconductor industry means for all of us in day-to-day life, and every possible country and geography has awakened and realizing the strategic importance of this sector and trying to do so. So India can never be left behind. We are going to be $5 trillion economy, and semiconductor and electronics are going to be the backbone of that $5 trillion economy. And I think Honorable Minister is going to talk more about it. But in last 2 years, India has put basically very comprehensive policy framework for developing the semiconductor ecosystem in the country, not just fab or manufacturing, but all the way from research, talent and skill development, fabless and IP companies, manufacturing, supply chain ecosystem. A comprehensive framework has been created, and in my basically 20 years working with the government and the policy framework, I think this is the golden period for India in the semiconductor industry. So there cannot be any better platform than this VLSI conference to acknowledge, realize and make it happen. One thing at VLSI Society we are trying to do, looking at the current geographically realities, we are trying to expand the VLSI design, fabless companies, IP companies, not basically limited to few cities. The few cities like Hyderabad and Bangalore will become anchor, but we want to take it to every part of the country. And towards this effort, we plan to open 7 regional chapters for the VLSI Society India. And if every 20 regions of the country can give 10 fabless companies to the country, we will soon have basically 200 thriving fabless companies in the country. So once again, welcome on behalf of all of us to this wonderful event, and big applause and kudos to the team Hyderabad. Last 6 to 9 months of extremely intense effort and came out with a very impressive event. So thank you so much, Sanjay, Ajay, and all the other people basically who put together this team. So big applause for the team Hyderabad, and thank you.
Thank you, Dr. Satya Gupta, for taking us through the conference inception and the highlights. Now like to request our esteemed guest, Srimati Jaya Jagdish, Conference Executive Chair and Country Head of India, to address the delegates.
Good morning, everyone. It's indeed my pleasure to be addressing this illustrious gathering with eminent leaders from the government, from the industry, and academia. Chip design or semiconductors were probably lesser known terminologies until about a couple years ago. Semiconductors did not really have its own unique identity until recently. I think for many of us, long-timers like me, It was kind of bothersome to make a special effort to make people understand what we really do and how important it is. A lot of the work that we do was really clubbed under the bigger umbrella of IT. Now, last couple years, it feels like a new world. This whole narrative is changing slowly, thanks to the huge demand for chips worldwide, and thanks to the huge momentum and focus placed by the government of India to improve and strengthen the semiconductor industry. We honestly feel it's a new world. A lot of momentum has been built, a lot of awareness has been created to enable the semiconductor industry and strengthen the ecosystem. I was truly delighted, like a little kid, when our Honorable Prime Minister mentioned semiconductors in his address to the nation. It felt like India has woken up to semiconductors. And for the first time, I felt like I was at the right place at the right time. We have come a long way in creating that awareness and building that momentum, but it just is the start of a journey. The whole awareness or momentum that we have built needs to really translate into many more investments coming to India, manufacturing really taking off with fabs being set up, many more students opting the semiconductor industry to build their careers, many more emerging startups in the industry, and finally advanced research and development happening with the cutting-edge technology. All this needs to lead into a very robust, sustainable ecosystem with great employment opportunities. The focus on semiconductors or chip manufacturing or design is not something that's unique to India. It's happening worldwide. There are many countries who are making changes to their policies to invite more investments and to achieve self-reliance in chip design and chip manufacturing. However, very few countries have the potential that India holds. With access to huge manpower, with lakhs of engineering graduates coming out every year, I believe we in India have the ability and the potential to create the skilled labor, not just to suffice India's needs, but to actually meet the global needs. It's, again, the whole education system, academia, and the industry needs to partner with able support from the government to really make this happen. And we see the right focus being built in terms of generating skilled labor and creating skilled labor. In that regard, it was truly an honor to work as the chairperson for the Committee for Talent Development and Skill Development. The committee was put together by our Honorable Minister of State, Shri Rajiv Chandrasekhar, and had representatives from government, industry, and academia. The seriousness and the passion that existed there in the committee was amazing, and we have come up with a set of recommendations that was submitted to the government by end of November to really make India the hub for semiconductor talent. Research and development is another critical aspect. While the focus on employability is huge, which rightfully should be, we cannot ignore research and development. Both employability and R&D need to go hand in hand for any growing industry to thrive. So the committee has been focusing on R&D as well, and we have submitted a set of recommendations for R&D aspects. We are looking forward to implementing these recommendations. Events like this, the VLSI conference, are hugely critical and important. They build the awareness, they showcase the potential of the talent that exists in the region, and also foster a culture of innovation. AMD is truly honored and glad to be the silicon sponsor for this event, and we are deeply committed to doing our bit to strengthen the semiconductor ecosystem in the region. It's truly an amazing time. We have a mountain of an opportunity in front of us. Let's work together to make India not just a hub for semiconductor talent, but also a hub for semiconductor products going forward. It's up to us. Each one of us can become evangelists to promote the semiconductor industry, and that's truly the need of the hour. Thank you so much for giving me an opportunity to speak. Glad to share my thoughts with you all. Thank you.
Thank you, Ms. Jaya. I now request Chief Guest, Honorable Union Minister of State, Ministry of Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India, Sri Rajiv Chandrasekhar, to address the delegates. Please note we're trying to connect to him remotely. Give us a minute. May I now request our Chief Guest, Honorable Union Minister of State, Ministry of Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India, Sri Rajiv Chandrasekhar ji, to address the delegates in the conference.
Good morning. Good morning, ladies and gentlemen. Thank you for inviting me to speak here at the 36th International Conference on VLSI Design and the 22nd International Conference on Embedded Systems. I thank you all for giving me this opportunity to speak here. Let me quickly share some of my thoughts with you. I think this is an important event, and more than that, I think it is occurring at a time when the opportunities in front of the whole VLSI community and the VLSI ecosystem in particular, and the electronics and the embedded systems ecosystem in general are expanding at a hitherto unprecedented pace. Let me just take you back to some years ago. In 2015, our Honorable Prime Minister launched his vision, his dream of digital India, and his objectives when he laid this out in 2015 were extremely clear and in many ways prescient. I was in the audience just like you are today, and even I was not truly confident about the vision that he laid out in 2015 and how far we would travel. He essentially, in 2015, laid out three broad outcomes or three broad goals that the country needed to meet. One was clearly that technology would be used increasingly to transform the lives of individual citizens and transform the process of governance and democracy, which for long India had been seen as a very dysfunctional governance, dysfunctional democracy. So he wanted technology to be used more and more to bridge the gap between both the trust gap and the actual public services gap between government and citizen. He wanted, as a second leg of his basket of goals, he wanted the digital economy to grow. He wanted the innovation and opportunities ecosystem to grow for our young Indians. And the third is, he said in 2015 that India, from being a consumer of technologies, must transform into a front runner, a leader in terms of producer of technologies, platforms, devices, products in the coming years. So broadly, this was a vision that he set out 8 years ago. And as we sit today in 2022 and are talking about the India decade in the coming years, the decade of technology opportunities, and as we speak to not just India decade, we also speak to our ambitions of India as a semiconductor nation, it is absolutely reasonable to be pleasantly surprised, happy, pleased with the distance that we have traveled as a nation over the last 8 years. Most of you would be aware that prior to 2014, when there was a mention of the digital economy or indeed the technology ecosystem, in large part this referred to the technology services business and the large companies that had been successfully built over the previous decades as a technology service provider for various companies around the world and various enterprises around the world. And if you look into 2022, the digital and the technological ecosystem has since been re-architected and, in a sense, significantly diversified. And the expanded opportunities today range from technology services, which was the sole defining category a decade ago, to the full spectrum of innovation in technology. So the India decade is not just about the future of the internet, not just the future about D2C and consumer tech, but also as much about electronics and semiconductors. So let me narrow focus on that a little bit now that I've laid the background for you in terms of where we were in 2014, where we have traveled, and what our ambitions for the coming decade are going to be. It is clear today that we are living in extremely interesting and exciting times. I'm sure that most of you who are professionally involved or involved in business ways in the semiconductor and the embedded systems ecosystem understand the trends that are pointing to essentially the best time ever for this ecosystem in the coming years. The global trends that we clearly know are the increased digitalization of governments, enterprises, consumers all around the world, leading to an increase in demand of digital products and platforms and devices and services. Second trend, which is that there is a increasing demand for talent in the entire full spectrum range of technology and digital capabilities. And the third trend is that of as the supply chains and the value chains are being redesigned and re-architected around concepts of trust and innovation as a combine rather than the earlier defining attribute of supply chains, which were price and efficiency alone. So if you look at these three, I think it is clear that our ambitions for India as a semiconductor nation, India as an electronics hub, are increasingly not just relevant for India and our ecosystem, but also for the world at large and the consuming world in particular at large, and the innovation ecosystem, the global innovation ecosystem in particular. Our journey in the last 5 years in the electronic space has been fairly steady, significant, and in the post-COVID in a sense, changing value chains and supply chains, we seem to have hit the stride, and with categories like mobile phones and other on the device side, and soon in the server and the hearable wearable sides, we will be, and of course in the deepening of the electronics ecosystem into the components and the semiconductor side, we would soon be capitalizing on our momentum and our growth and our presence and increasing acceptance of India as a hub for electronics into the other areas of semiconductors and components as well. The India Decade, as I said, and the Honorable Prime Minister said very recently, and I quote, it is our collective aim to establish India as one of the key partners in the global semiconductor supply chains. We have to work in this direction based on the principle of high tech, high quality, and high reliability. End quote. This is what the Honorable Prime Minister said in the first ever Semicon India conference in Bengaluru in early 2022. So I think, I'm sure that most of you are aware of the initiatives that the government of India has taken, including the India Semiconductor Mission. The Prime Minister has very quickly and responded to the changing global opportunity space in semiconductors and has set aside $10 billion to invest in, foster and catalyze the semiconductor innovation ecosystems in India. The India Semiconductor Mission that was set up very quickly. We have almost the finest minds in global semiconductors in terms of experience and capability and credibility, with names like Vinod Dham, Patrick Sequeira, Rao Tumara, all on the India Semiconductor Mission, and they are actively today looking at a broad spectrum of opportunities ranging from design all the way to manufacturing. The next generation of devices can be designed out of India, can be manufactured and fabbed in India and packaged and verified in India, and in turn find place in products and solutions that are also architected and devised in India. In addition to the India Semiconductor Mission, we have also launched the DIR-5, which is the RISC-V program, with Professor Kamakoti of IIT Chennai as the chief architect of the RISC-V, India RISC-V program, which we have branded DIR-5, which is Digital India RISC-V, and that has a full-time program manager assigned to that program from CDAC, which is one of the government higher technology institutions that is working on it. So by 2024, we believe India would have stepped into the semiconductor manufacturing space and clearly catalyzed a larger, a more domestic design and innovation ecosystem, where we are encouraging startups to work with the leading majors, global majors, to develop IP, to develop devices, either co-owned or owned, for which the government has announced the Semicon India Future Design Program. And the Future Design Program is a program where the government has about $200 million to invest in startups that will, like I said, design or co-design IP or tools or devices for the next gen of applications in India. And we have, just to share with you, to make sure that these devices and this innovation ecosystem is fully supported by market, we will soon be launching an IT server and an IT hardware PLI that will be very similar to the mobile phone PLI, which has been extremely successful. And one of the things in the IT PLI is that we will create additional incentives for those manufacturers or OEMs that incorporate Indian designed IP into their systems, into their products. So in a lot of ways, we are putting government capital to work in actively catalyzing the India semiconductor ecosystem. We are working extremely hard with industry and with other elements, including our global diaspora, to ensure that our ambition of India as a semiconductor nation will be realized very rapidly. I must point out to many of you here, all of you are, I'm sure, passionate about VLSI and embedded systems and the future that these two segments represent for the innovation ecosystem in general. But I must tell you that what the government of India and what India and all of us are trying to achieve in the next 5 years is what most countries, including the country in the North, China, have attempted to do over multiple decades. So we are, in a sense, operating and working at a torrid pace. It's a phrase that, the phrase torrid is a phrase that I have borrowed from my old boss at Intel, Pat Gelsinger. He uses that phrase a lot. So we are working at an extremely torrid pace to achieve what I believe is really, in some sense, and this may sound a little melodramatic, but tryst, our destiny, our tryst as a nation, as a semiconductor nation, to truly unleash the talent and the capabilities that have existed in India for many, many decades, but have never had the opportunity to break out and shine. So I will leave it at this. I wish all of you great success. I wish your deliberations all success, and I look forward to continuing to work with you and engage with you as we work together to take India down this path of truly becoming a semiconductor nation and developing global standard capabilities in semiconductor design, manufacture, packaging, and indeed the entire ecosystem of embedded systems and electronics for the future. Thank you again. Jai Hind.
Thank you, Honorable Minister Shri Rajiv Chandrasekhar, for sharing your thoughts and laying out your inspiring vision on VLSI ecosystem and growth in India. May I now request all the dignitaries to please come back on the stage? I now request our esteemed guest, Principal Secretary for Information Technology, Industries and Commerce of Government of Telangana, Shri Jayesh Ranjan, to please come and address the delegates.
Thank you. Thank you very much. Honorable Union Minister of State for Information Technology, Shri Rajiv Chandrasekhar Garu, our special guest, Mr. Victor Peng, Srimati Jaya Jagdish, Mr. Shashi Reddy, Mr. Satya Gupta, Mr. Venkat Simadri, all the invitees, guests, participants. First of all, a warm welcome to all of you on behalf of the Government of Telangana. I would also like to convey the greetings of our Minister for IT, Mr. K.T. Ramarao. He very much wanted to attend this conference, but something very urgent came up in his constituency and he had to leave for his constituency. But he has conveyed his best regards and warm wishes for the success of this very landmark conference, which is happening in Hyderabad after many years. I'm also very delighted to see such an overwhelming response to this conference. In fact, the organizers told me that they had to stop registration because there was no space to take any more people. But definitely something which is very heartwarming, that there is so much of enthusiasm And as you heard other speakers, Honorable Union Minister Jaya ji, Mr. Satya Gupta, the sense of optimism about the growth of the semiconductor industry, the embedded systems, VLSI industry, that is very, very real. There's no exaggeration, and we are seeing it all the time ourselves, the kind of disruption that semiconductors, VLSI, embedded systems are causing in different walks of enterprise today. In fact, we have seen that advancements in semiconductors have really changed the face, let us say, of space technologies, of automotive industry, of smart industries, of smart manufacturing, of IoTs, even basic home appliances, devices that we use. We have seen amazing ways in which these devices are now performing as compared to not even the recent past. And all this is happening due to rapid strides which are being taken in this industry. Today, again, I feel very proud that while the advancement in knowledge, advancement in technology is happening the world over, it is units in India, the design centers, the development centers, the manufacturing sectors in this country, which is playing a very vital role, which is making a very significant contribution. And again, I feel very proud that Hyderabad, along with other Indian cities like Bangalore, to some extent, Pune, Gurgaon, is at the forefront of providing this kind of think force to really support the industry. The who's who of the industry are present in this conference today, and I'm delighted that some very eminent speakers are going to share their thoughts. I'm also very happy to see that so many students have registered for this particular conference, because they are the ones who tomorrow will be joining many of these companies. Some of them potentially can become entrepreneurs, and they are the ones on whom huge responsibilities will lie. And therefore, participating in an event of this kind, where the stature of our speakers, stature of our delegates is unparalleled, definitely will be a very invaluable experience for me. I would like to also share a few kind of highlights on what is the importance this sector is getting in our state of Telangana. As Jayaji mentioned, it was not very long ago that semiconductor had its own identity. People used to club semiconductor as a part of the larger electronics industry, the ESDM industry. But I can share this with you that in 2014, when the state of Telangana came into being, and we were given a mandate to draft our policies afresh, organize our government department in a very agile and business-friendly, ecosystem-enabling manner. We recognized the importance of semiconductors at that point itself, and our department had a separate wing, which was called the Wing of Electronics and Semiconductor. Similarly, with lots of foresight at that point in time, we also created another wing which was promoting advanced computing technologies like photonics and quantum. So since then, since 2014, the sector holds prime importance for us, and the accomplishments over the last 8 years are indeed very, very encouraging. As I mentioned, the who's who of the VLSI industry, the ESDM industry, they have found their homes in Hyderabad. All the senior people who are on the stage themselves, from AMD, from Qualcomm, from Intel, MOSCHIP, you name them, they have large footprints in Hyderabad, and they are doing some very, very significant work out of their development centers here. And again, something which is very heartening is the kind of growth these centers are witnessing. Since Sashi Reddy Garu is here on the stage, I can mention this, that Qualcomm, which had, of course, a significant presence a few years ago also, has now tripled their headcount in the last few years, and they are poised to grow even more and more. And this is the story which is literally shared by everyone, all the majors who are here in this city. So government, of course, has played an important role in this ecosystem building. There are two specific initiatives of ours that I would like to mention briefly. We are also focused on skilling. Since I learned that Jaya Garu was heading the committee which was constituted under the India Semiconductor Mission to look after talent development, etc. I'll be happy to share with you that we have started a very focused initiative on skilling, again with the help of the industry. We have identified the kind of courses with students who are already pursuing other branches of engineering they should be equipped with while they complete their degrees. We have also identified courses which, after completing their regular engineering courses or other science-related courses, STEM courses, what are the other programs that the industry requires and that can be offered to the students as a bridge before they join the industry. And I feel very happy to share with you that we have conducted quite a few batches on RTL, on physical design, and we have used virtual means, in-person classrooms. We even have a government-owned satellite channel called TSAT, and the programs on VLSI have been broadcast using TSAT as well. And many more batches are being planned for the future as there is an acute shortage of skilled HR in this particular domain. We also have a skilling institution of the government called TASK, the Telangana Academy for Skills and Knowledge. And TASK is also now revamping many of the VLSI courses which can be introduced while the students, as I say, pursue whatever else they are studying in their colleges. We also understand the importance of innovation. Honorable Union Minister spoke about a while ago. We all know that some of the most transformative technology breakthroughs the world over is happening through young entrepreneurs, through young innovators. And Telangana also, Hyderabad in particular, has become a hotbed of innovation over the last 7-8 years. We all know about our innovation centers like T-Hub, T-Works, V-Hub, etc. And to give a specific focus on VLSI, we have started a virtual incubation program, a platform which is called T-Face, Telangana Fabless Accelerator through Cloud Enablement, which is an innovation platform for budding entrepreneurs in the VLSI domain. This is a very unique and special program which attracts not only national but also international attention. This is a virtual program being offered through cloud. Cloud spaces being offered to startups for both computing and storage. And the focus of this platform is on alternative computing technologies such as photonics, compound semiconductors, third-generation semiconductors, and quantum technologies. We see all over the world, and this is again a trend which all of you are, I'm sure, much more familiar than anyone else, that quantum technology, the semiconductor technologies that are prevalent now, they are also witnessing transformation, and the emergence of alternative technologies is inevitable. And therefore, we are focusing on these technologies which we see the whole world is moving towards, and we can definitely match global efforts because there is no link with legacies for adopting these kind of technologies. This particular initiative, the T-Face, is a collaborative platform. I'm happy to share that industry bodies like IESA, Hyderabad chapter, academic institutions like IIT Hyderabad, IIIT Hyderabad are providing technology mentorship. T-Works is providing prototyping services. T-Hub and TI are providing, TI Hyderabad chapter are providing business mentorship. And EDA companies are providing free EDA tools, licenses, and industry in general are providing resources and services. There are more than 30 startups currently who are getting support through T-Face, and there is a pipeline of another 50 startups who will be supported in the arena of interdisciplinary cyber-physical systems for use cases such as autonomous cars and drones, etc. We see that innovation is something which is very much required for the industry, and it gives a very good pipeline also for industry to collaborate and become more entrepreneurial, more agile, and more innovative in meeting the requirements of different sectors for the VLSI systems. I'm confident that the conference which is happening here over the next few days will be seen as a landmark in terms of new ideas, new thoughts, new collaborations. I also look forward to visiting the exhibition area, which is happening in the next hall, where again I was told that the response has been overwhelming and space had to be rationed because of the huge demand. Again, these are good problems to have, and I do hope that all of you, particularly those who have come here from outside, will have happy memories of your stay in Hyderabad, of your participation in this conference. And I once again congratulate the VLSI Society of India for bringing this event together. I'm sure that your experience of organizing this in Hyderabad is far smoother and far more economical, affordable, cost-effective as compared to many other cities. And I do hope that you will be bringing this conference more frequently to our great city. Thank you very much once again.
Thank you, Shri Jayesh Ranjan Garu. That was an inspiring roadmap that you've laid out, and it's really wonderful to hear about the task initiatives, the T-phase, and the many more skill development initiatives that you've been talking about. Now, I'd like to request Shashidhar Reddy Garu, Vice President of Engineering, Qualcomm, to join us on the stage and deliver a vote of thanks.
Good morning, everyone, and welcome to the VLSID conference 2023. I'm really glad to see you all here. After 2 years of doing it remote, having it physically and in Mana Hyderabad is definitely very glad to see that. I'm sure the conferences which many of us have been attending, there are a lot of new relationships, a lot of new friends we make in these conferences, both professionally and personally, and then also learn a lot in talking to each other and also listening to a lot of these technical discussions which happen the next 2-3 days. If you look at the industry in the last few years, there are a few major trends that were happening. Definitely the huge deployment of 5G across the globe, which definitely as Qualcomm, I would say that's a major success of having the next generation of wireless technology being deployed across the globe. The artificial intelligence, which is being very widely used both on the cloud and on the edge, that's really taking off, which is spawning into multiple different products and different areas which were unheard of. So if you look at automotive, which was a very, very mechanical device, it's becoming more and more like a mini computer, or not just a mini computer, it's more a computer run thing. And then in the IoT, obviously the smartphones, and many other technologies. If you look at it, there's no more interesting times than now, I would say, for both semiconductor and VLSI industry, and obviously the software, the embedded systems. So, in looking at those areas, our organizing committee has put up a very, very interesting and very interesting technical discussions and panel discussions as well as presentations from world-class technocrats who have come across from different parts of the world. So please do participate in those and make the best use of it. I would also take this opportunity to thank many of our dignitaries today. I would like to thank our Honorable Minister of State, Mr. Sri Rajiv Chandrasekhar ji, for joining us remotely and laying out the vision of the India government, the Union government, and how semiconductor is important for it. I think that's music to our ears, to many of us here, because we have not heard as much on semiconductor, even though we were doing it for many, many decades in India. I think there's a lot more focus on how to improve and increase the semiconductor presence in India, as well as bring in manufacturing to India. I think that's been normally what was used to happen in other countries like Taiwan and other countries. A lot of focus and a thought to bring that, and different plans to be made to bring that to India definitely will help us grow the industry in India and build our careers around it in India as well. I would also like to thank our dear Principal Secretary Jayesh Ranjanji, who many of us know, both personally and professionally. He's very, very accessible, very passionate and key driver for innovation and what's happening in Telangana, in government of Telangana. So I would like to thank him for giving his ideas as well as laying out what are the different ways we can improve and bring things into government of Telangana, into Telangana, and what kind of support we are getting from government of Telangana. Me being in Hyderabad as Qualcomm for the last 18 years, we have taken many of those help and aid which is coming from government, and I think it's not normally. I tell many of my colleagues outside Hyderabad that it's just one phone call away to contact the government, and very, very friendly government which we had really helped us grow, not just Qualcomm but many other companies, both in semiconductor as well as software in India. And thank you, sir, for being here today. And I also like to thank Victor Pink to have come all the way. We are definitely looking forward for your keynote today and learn from your experiences in Xilinx and AMD. I would like to thank Jaya Jagdish for being here. Definitely, I can't agree more. We were really lucky to be part of this industry, the right time, right place. We're all there, and as you had mentioned in your speech. So it's definitely an exciting time for all of us. And last but not, Satya Gupta being here, thank you so much. And Venkat Simandri, my friend and colleague from the Hyderabad ecosystem. He's the CEO of MOSCHIP. So thank you for being here. And all the friends and colleagues from the industry, thank you for being here. And definitely I also want to thank all the industry sponsors, AMD, Qualcomm, obviously, we've been the silicon platinum sponsors, but we're also all the different companies like Anisys, Alphaware, Marvell, Micrologic, Siemens, Silicon Labs, Cadence, MOSCHIP, Intel, and many others. Without that, this conference would not have been possible. Thank you again, and have a great time.
Thank you, Shri Shashi Reddy Garu. I request Srinivas Bayari, Organizing Chair of Conference, to present a memento to the Principal Secretary for Information Technologies, Industries and Commerce of Government of Telangana, Shri Jayesh Ranjan Garu. May I now request Shri Dasharatha Gude, also known as GD, Chairman and CEO of Invecas, to present a memento to the President of AMD, Mr. Victor Peng. I request Mr. Rafiq Somani, Country Head of ANSYS, to present a memento to Sri Shashi Reddy, VP of Engineering at Qualcomm and the Exec Chair of Conference. I now request General Chair of VLSI Design Conference, CEO and MD of MOSCHIP, Sri Venkata Simhadri Garu, to present a memento to Srimati Jaya Jagdish, Country Head of AMD India and the Executive Chair of the conference. I request Mr. Naveen Bishnoi, Country Head of Marvell Technology, to present a memento to Sri Venkata Simhadri, CEO and MD of MOSCHIP and General Chair of VLSI Design Conference. May I kindly request Sanjay Churiwala, General Chair of Conference and Corporate Vice President at AMD, to present a memento to Dr. Satya Gupta, Founder of CEO of EPIC Foundation and Steering Committee of VLSI Society of India. We now request the dignitaries to inaugurate the exhibit hall, and I request our exhibit chairs of VLSI Design Conference 2023, Mr. Sangram Jena and Mr. Prasad Haldule, to escort our dignitaries to the exhibit inauguration. We request all the attendees to please kindly be seated. We will return back to this main hall after a short 30-minute break. Our next session will begin with a keynote address by Victor Peng, President of AMD, on high performance, adaptive, heterogeneous computing for the intelligent digital world. Please enjoy your tea break.
Hey. Check. 1, 2. Check. Check.
Hello? Hello? Hello?
Is this okay? Yeah. I hold it about this or closer? Is this good? Okay. Yeah. You know what? Never mind. I'll go back. Okay. Test 1, 2, 3. Test. Yeah. Okay. How's that? Yeah, I think people. Yeah, it's just good. Yeah, yeah, yeah. Okay. Okay. Yeah, I think it's pretty loud. Okay. Yeah, let me put this here. Oh, yep. Hold on. Okay, test. Hello, yes. How does that sound? Is that good? Test. Yep. Sure, yeah. Test, test. How's that? Okay? Okay. 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 Mhm. That's fine. I'm going to turn it off.
Welcome back, everybody. I request everybody to please kindly be seated. So we will now begin with the keynote address by Victor Peng. Heterogeneous, high performance and adaptive computing are the bedrock for a hyper-connected and digitalized world. A world that continues to see massive growth in data. Moreover, businesses and society are unlocking value from data by the ever-important need to turn insights into intelligence, made possible through pervasive AI. Please join me now in welcoming Mr. Victor Peng, President, AMD, to share his thoughts on high-performance, adaptive, heterogeneous computing for the intelligent digital world.
Thank you so much. It's an honor and really a tremendous pleasure to be here. I'm going to just share a little bit of my thoughts around, as the world digitizes, what the future of computing is going to look like in order to deal with this massive amount of data. So I'll talk about three basic trends, which of course I think you're all fairly well aware of. One is just the explosion of data that's occurring, right now today and still growing exponentially. And then how part of the solution and how to extract information and insights from that data is going to be enabled by AI. Now, the good news about that, of course, is that's the only way we're really going to be able to keep up with this tsunami of data that's being generated on a daily basis. On the other hand, it also presents some challenges because AI itself also requires a tremendous amount of computing as well as memory and also data movement. Then the last thing I'm going to talk about is the fact that, I think today everybody accepts that computing, future computing, and I do mean computing in the broadest sense, both embedded, since we're talking about embedded applications, but also in traditional computing applications, really is about heterogeneity. In other words, it's not one single architecture that can handle all the different kind of processing capability that we need. It's really going to be heterogeneous. So CPUs and GPUs, FPGAs, adaptive SoCs, and even more special purpose ASICs or ASSPs. All of those are going to have a place and be required. But also I think really when then you look at that, I'll talk finally about what AMD is doing to contribute to this future of computing. So as I said, it starts with data. So why don't we just start there? In all these areas, hopefully we could advance the slide. There we go. So digitization is occurring, in virtually every industry, every application from, it was mentioned earlier, from electric vehicles, that today are highly safe but moving to full autonomy, to smart cities, healthcare, of course, the digital home, traditional computing space, which here in India, there's a thriving new emerging space, both governmental and also commercial. Of course, industrial, the next generation of factories, right? So all these things are generating data on a daily basis. Much of that is video, but not all of it is video, right? And a lot of that video is being generated by content creators, but also by devices. So there's estimated 720,000 hours of video being uploaded to YouTube on a daily basis. We talked about cars. In premium vehicles, like today even, that you could be built, purchasing a vehicle that has up to 200 different sensors. And there's a diversity of sensors, right? There are cameras around the entire vehicle, pointed outside the vehicle. There's also cameras pointing inside the cabin, right, for driver monitoring things, for gesture recognition for passengers. There's sonar, there's LiDAR, there's radar, there's temperature sensors. I mean, all kinds of different electromechanical as well as different forms of, wireless kinds of technologies. And only in, 2 to 3 years, some people estimate that machines and devices will be crossing over the data generation versus humans, right? So, once again, data is not information, and what we need to do then, this is really driving, virtually an infinite demand for performance. And I would argue, which I'll spend a little bit of time, helping you understand the value of adaptive computing, and that will translate into both, information as well as insights, some of which need to be acted upon immediately. So in embedded applications, like I mentioned, the automobile, obviously that's real-time data being generated, and you are going to have to respond to it, particularly in applications like ADAS and autonomous driving. Okay, so if you look at this, I mentioned performance is virtually limitless. If we look at supercomputing, sort of the pinnacle of computing, we're very proud at AMD that we, working with HPE and the Oak Ridge National Labs, finally broke the exascale computing barrier, right? In fact, it's 1.1 exascale. So that, again, is the way to think about it is, again, a billion gigaflops, right? A billion gigaflops. And something, as proud as we are of the fact that this is the highest performing supercomputer, this is announced, achieved last year. At the time, it was the #1 green supercomputer as well. Today, it's #2, and the one that just recently kind of, became a little bit more power efficient on an absolute performance basis is much lower. This is really critical, and I'd say it's not only an imperative for the industry, but it's an imperative for society because, the power of this kind of computing is, also growing quite high, and there's no way that we could sustain, linear extrapolation in terms of the computing we're going to generate, not only in supercomputers, but even, our embedded products. So we're quite proud and we're very focused at AMD on not only achieving high performance, but achieving it in a very sustainable way. This is done, both with our EPYC CPUs as well as our MI Instinct GPUs. You can see, it took over, over 37,000 GPUs and over 9,000 CPUs to achieve this technology, this milestone. But again, I kind of mentioned that when you're talking about zettabytes of data being generated and that increasing on an exponential basis, even the rate of improvement of supercomputers is not keeping up with the need for computes. So if you look at the graph that's sort of on your the lower left, it's showing that supercomputer performance has been actually doubling every about 1.2 years, which is actually quite impressive, right? And again, you see that data point where it's showing we achieved the 1.1 exaflop. But now if you look at the compute requirements for training AI models, right, over the last several years, That's doubling about every 3.5 months, right? And that's been going on for many, many years, as you can see. Not only that, but these model sizes are getting larger, right? Particularly these new large language models. I think many of you have kind of heard or tried ChatGPT. Those are, generative transformers. It's also very large recommendation engines. They're also getting huge in terms of the memory that required, the parameters that they have. We're talking hundreds of billions to actually growing to trillions of parameters. So again, the good news is AI is going to help us take huge amounts of data and translate that into insights and information. On the other hand, AI itself, particularly training, but also very dense inference, requires a lot of compute as well as memory bandwidth, as well as then data movement, bandwidth in terms of whatever system that you're in, whether that's an embedded system or whether that's a computing infrastructure. So the good news is, it sounds like a challenge, but the good news is, and this is why it's great for all of us to be in technology today, is this is driving incredible innovation, right? This is driving innovation in architecture, innovation in technology, in physical design. It's just because these types of growth rates, the old way of doing things is just woefully short, right? Like, we have to innovate from an architecture, from algorithms, from all kinds of dimensions. So, earlier, I guess I would say we're almost at the 1-year anniversary of when the acquisition of Xilinx got completed with AMD. Last year we announced one of the new strategic pillars of the company is that we are going to be working on what we call pervasive AI. And this is just a little graphic to say, like, I'm sure that if you're all familiar with AMD and everybody recognizes that we're in both computing infrastructure, home, smart home, entertainment and things. But when Xilinx joined forces with AMD, we're also in all these other embedded applications, right? Which is, again, an important theme of this. And every one of these industries, whether it's transportation, healthcare, the digital home, infrastructure, communications, aerospace, they're all going through that transformation of digitization, and they're all applying AI technology. By the way, all this intelligent kinds of infrastructure are going to be all connected together through both wired and wireless interfaces, and communications infrastructure is also adopting AI, whether it's intelligent beamforming or other kinds of forms of, in wireless technology, other kinds of, dynamic, adaptive kind of techniques. So I think it's true today that whether you're aware of it or not, in your daily life, you're using some infrastructure or some product that is powered by AMD technology. And so when we talk about the fact that we have to, and we are committed to enabling AI end-to-end, we really mean end-to-end, right? So we talk about in terms of what I'd call endpoints. So that could be a single camera or a single sensor, to edge devices. Again, that could be a vehicle, it could be a robot that has multiple sensors and actuators, and that typically will get connected up into the cloud, whether it's a public cloud or a private data center. So, now I already talked about this. Like, it's hard to sort of wrap your mind around the fact that the reality is, if 10 years ago I was up on the stage and I was talking about computing, the world was CPUs, microprocessors, microcontrollers do computing. Storage is storage, memory is memory. And in fact, if you said something was intelligent, it's just because it has like a microcontroller or a microprocessor in it. Now when we say intelligence, we clearly mean AI. And it's not just one AI. Many of these systems we'll talk about in a moment really have a multitude of different AI models, and they're all used in even just one application. So again, I think it really is that you're going to see there's innovation, and there's a lot of discussion, and there is innovation around domain-specific architectures. There's domain-specific languages, and so there's the whole spectrum of what I would call the ability to support multiple workloads and multiple different types of computing problems, to, in some instances where you want more specialization, and under certain circumstances you really want to just optimize to either a single workload or a very small number of fixed workloads, you're going to really need to span this entire environment. And so one of the really good things about the new A&D, which is a combination of Xilinx and A&D, is that we really do support this entire spectrum, right? And I think many more other companies here are on a similar journey of making sure that they could support all these important engines, because there's really not one single architecture that's going to be able to support all the workloads that we're seeing even now today, but will be even more so in the future. I think most people understand this, and what I'm going to talk a little bit more about in a moment is a little bit more about adaptive computing, because that's probably the one that's still mostly understood by everyone. And I'm going to do that in the context of our latest generation product, the Versal architecture. Now, we talk about, everybody's kind of familiar with general FPGAs, but over a decade ago, we introduced what we call adaptive SoCs, and that's integrating a full multi-core SoC together with FPGA fabric. And so we refer to that as adaptive SoCs. Versal goes a step further, so sometimes we refer to this as an adaptive compute acceleration platform, ACAP. And the reason it goes further is not only because it has even much more powerful multi-core SoCs, both what you might consider applications processors as well as real-time processors. It also has a hardened network on a chip. It has next generation FPGA fabric. It also has the AI engine, which is a new scalable architecture that I'll talk a little bit more about for AI, but as well as other kind of signal processing. And it has a plethora of hardened blocks that, even though they're hardened blocks, are still quite configurable. And so this enables a single architecture to support not only different workloads, but actually completely different industries, right? So this is used in data centers, it's used in wireless networking, communications, automotive, industrial, and so forth. The other thing that we talked about is, so A&D already has what we call RDNA, so GPUs that are focused on gaming. We have CDNA for GPUs that are Instinct line, focused on data center GPU for high performance computing as well as AI training. And now, with the acquisition of Xilinx, we have what we call XDNA. And the two main architectural IP that comes from Xilinx that we're going to leverage is the base FPGA fabric, which has the programmable logic, has lots of distributed memory, programmable interconnect, as well as programmable DSP blocks. We're going to mainly focus on the AIE engine, and this is a very scalable architecture. Each one of these engines are superscalar VLIW engines. They have local memory, but they also have independent data movers. And again, some people refer to these types of tiled architectures as spatial architectures. The way they're implemented is like you would implement an ASIC, but again, each engine is quite configurable, as well as the interconnect topology is configurable. So just to help explain two things, I kind of talked about end-to-end pervasive computing. The compute requirements and the memory requirements are nearly insatiable. So that's common whether you're talking about embedded applications or traditional computing applications. But there are differences in some of the other requirements in these systems. So on the left, we have what I call edge requirements. And this could be also, the same thing works for like what I would call an endpoint. So while you still want high performance, you also typically need low latency, if not indeed real-time constraints. You're usually really trying to do a more fixed, if not a single workload, or a relatively small set of well-known workloads. Your resources are more constrained, and quite often the form factor, the power, and the cost is quite constrained. On the other hand, when you're talking about an enterprise or certainly a public cloud infrastructure, there you have a much, much broader set of workloads. There you could have variable latency, so you're not as, it's not in all cases that you're required for very low latency. The workloads not only change, by the way, from year to year, but in a single day, the type of workloads you might be running in the data center is going to change quite radically. And in here, you really have a very large infrastructure, and so therefore scaling up as well as scaling out is really important. and I'll talk more about composability later. And there, some of the key, key success factors is really TCO, right? Getting the highest throughput performance in TCO. So first, I'm going to go through a quick example so you can get the contrast between requirements when you're at the edge and requirements when you're in the cloud. And I'll just pick a vehicle. What I'm going to try and do with this example is also work through why adaptive computing is also part of the equation of the heterogeneous future of computing. So this is just sort of showing a simplified pipeline of computing for something, advanced driver assist system, where you're getting multiple input streams, whether it's cameras or lidars or radars or a combination of those. You have to do some sensor fusion, image scaling, then there's region of interest, object detection, and so forth. I won't go through each one of them. The reason why the boxes are different is because that's meant to indicate the amount of compute resources and potentially other kinds of resources, memory, and data movement and bandwidth that's required. Certainly, it's clear that you have real-time constraints in this case. You need deterministic latencies, and you want it to be very efficient, both in terms of cost and power and form factor, because these are cars, and oftentimes these kinds of systems have very small areas to fit in, and the power is a big issue, of course. So I'm going to walk you through how this can get accelerated with like an FPGA architecture, but it's quite similar to what you would see in AIE, because I'll walk through that next. So I'll just look at a part of the computation pipeline. So the first thing you do when you have this, this array is you effectively you size up what kind of resources, compute resources are required for each of those different pieces of the processing pipeline. You quote unquote place those. It's not only so that you cover the amount of resources you need in an array, but it's also because the data flows, right? If you looked at that, data flows from the sensor inputs all the way through to route planning and evasive action and so forth. So you place all those, and you determine the connectivity, so you kind of route the data movement. And then, if this would advance, if you looked at it before, there was only 3 out of the 4 processing blocks placed. That sort of says that maybe you consumed all the available resources. But one of the other things that we can do is we can dynamically, in operation mode, reconfigure the accelerator to now process something different. So that's what we call dynamic function exchange. That's showing, you could kind of think of it as kind of like swapping the function in and out in hardware. Right? That's basically how adaptive computing on an FPGA works. If I were to then go talk about the other XDNA element, the AIE, you have the same sort of notion of you have an array of those AI engines, and you figure out how much you need to use for each of the functions, and then you can program the interconnect so the data just flows from one function to the other. The point that this graphic is trying to show you is that, okay, that's the AIE array, and then below that is still the rest of the programmable logic, of which you have more configurable logic as well as memory, different forms of memory, as well as off-chip memory ultimately. And the other reason why you can get really good performance with good efficiency here is that while you're doing processing, you could also be doing the data movement, and you could pipeline that, so you could essentially hide the latency of doing data movement from memory. And when people talk about performance, there's always an emphasis on sort of the data path performance. So it's kind of a little bit of a pet peeve of mine that when people talk about tops, they're really talking about peak tops, but nobody ever achieves peak tops. And it's because typically you're actually bottlenecked by memory or bandwidth or some combination of both. So the point here is to achieve really good efficiency and throughput, you also need to customize the memory architecture. And it's also trying to indicate that there's a lot of distributed memory within the AIE array itself. But then when you move out to the data fabric piece, there's also a lot of distributed memory that's also configurable. And then if you have to go off chip, there are many channels of DDR that can also be programmed. And every one of these things you can kind of tailor to the application that you're trying to accelerate. So you can see that there's different sizes of the bus, and you can see you have tens of terabytes of memory bandwidth within the AIE array. Then you go to single terabytes, and then you go to hundreds of gigabytes as you move through the memory hierarchy. Okay, so that was sort of a very conceptual. These are just block diagrams of real applications The one on the left is IVI for in-vehicle and infotainment architecture. And you can see how we have an APU, which is a CPU with also graphics embedded. And then we have that adaptive SoC or Versal product. So it's showing that, yes, indeed, we really are in embedded applications using a heterogeneous architecture to sort of do this sort of edge device. And you can see this is two independent chips. Could also be a chiplet kind of integration in a package. And the one right shows how we could integrate those together into a single chip solution for more of a functional safety, ADAS kind of architecture. Okay, so that was sort of an example of an edge application, truly real when we got to the final block diagrams. Now I'll talk a little bit about some of the trends on the cloud side, and then also what we have in terms of AMD providing technology there. So again, here you're not as latency sensitive, very large workloads, and you need to scale out. So I briefly mentioned composability before. Now I'll talk about it a little bit more. I mean, this has already happened. More and more workloads, not only need more than a single node, needs, in some cases, especially AI training, needs racks and racks and racks. I mean, we're talking about tens of thousands to even more than tens of thousands of server racks and GPU racks in order to compute, and train these incredibly large language models. But it's not just AI training. There's many applications that really have lots of different requirements for CPU, sometimes CPU with accelerators, whether that's a GPU or an adaptive SoC or FPGA. All of that is taking place more and more, where you need a lot of scale out, and of course you could always use scale up. And so I mentioned on the chip the fact that data flow and memory bandwidth could actually throttle your performance. Well, that's sort of absolutely the case too when you talk about the entire data center infrastructure. So not only do you need all these different heterogeneous engines, but you really need intelligent networking and fabric, so SmartNICs and other intelligent fabric to sort of have the capability to assign the amount of compute resources out of the pool of CPU nodes that you have, as well as assign the number of accelerators, whether that's GPU or FPGA or adaptive SoC, and also indeed even computational or intelligent storage, smart storage devices. So we see that trend, and ultimately, if you think about it, once you have true first accelerators are first-class citizens, with things like memory coherency and other things that you need to do, and you have those intelligent fabrics, now you really can be doing computing, all the time. In other words, when we refer to data in use is when the application that's running on the CPU, more traditional procedural code is running on that, and then you need to do some acceleration for something that's very parallel. You could do that, of course. You could also do more offload things where you're passing a larger job to one of the accelerators. You'd also be doing computing, in intelligent memory and intelligent storage. Indeed, you could even be doing computing as you're moving through the fabric or the network. So we believe that this is a trend that's already there and it's going to continue to grow. So what do we have to offer there? So our 4th generation EPYC CPU, 96 Zen 4 cores. I won't go through all the details. It's integrated in 5 nanometers. As you can see from this and others, we have gone to, AMD is a recognized leader in chiplet technologies. This is multiple dies integrated through other, whether it's 2.5D or truly 3D, where we stack things like cache memory on top of compute and so forth. And we have the Infinity Fabric to help stitch all these multiple die together. And we're seeing very significant, performance advantage versus the competition, both in absolute performance and once again in terms of, in this case, both integer as well as floating point. On the GPU side, the MI250X, here we show performance compared to competition as well as the performance per watt. And the MI250X is what was used in the frontier, right? We just announced last week at CES that later this year, we'll be coming out with the MI300, which is going to be taking advantage of the first chiplet kind of implementation for GPU. And you're going to see on top of these factors another 8x in absolute performance and another 5x in performance per watt relative to the MI250. And that will be more formally launched later this year. In terms of adaptive SoCs and accelerators, we also announced at the Consumer Electronics Show last week the availability, and it's actually, we have one of the cards, the acceleration cards in the demo booth areas, the V70. And, you know, at CS, we also announced that the first Ryzen, so, you know, desktop client kind of CPU that has the AIE engine in it. It has an array that can support, you know, up to 12 TOPS, 4 different multiple streams of AI processing. That same architecture, remember I mentioned it's a very scalable architecture, gets used in the Alveo V70, but this is a much larger array, so this supports 400 TOPS of AI compute, all in a 75-watt TDP. So, you know, we refer to this AI symmetry, and this gets back to end-to-end, right? You know, what we could put in a client device, what we could put in a car is the exact same inference architecture that you could see in the cloud with acceleration cards, and in the future, you'll see that we integrate this kind of XDNA technology across some of our server processors as well. And then I talked about, it's not only about the engines, but you need this intelligent networking. So we have both FPGA, where you can have really the ultimate, you know, both performance and hardware programmability, but we also have from the Pensando acquisition P4 programmability for a very easy deployment model. But if you think about it again, this is all about optimizing the traffic and the flows, offloading those CPUs, and enabling that composable and heterogeneous environment that we see moving in the future. And then, you know, what I would say is finally, I spent all this time talking about hardware, right? Typical thing for chip people. The reality is, without software, none of it really is usable. And in the end, software is, you know, super critical for people to really get real work done in applications. So we are absolutely enabling software developers. We're enabling the ecosystem, open source. Where at, you know, this stack is where we're heading. We don't have the full stack today. We have elements of it. I mean, currently with the different CPUs, GPUs, and FPGAs, each have their own stack. Of course, you know, we have ROCm, we have things for Zen, and of course Vitis and Vivado. But we are going to unify that, and so this enables people to target any one of these, you know, engines, and also indeed partition whether people want to do it manually. But you know, we look forward to being able to do auto partitioning so that, you know, the right engine is used for the right workload. And also that there's common tools and environments, and will still, of course, you know, interface to all the standard frameworks. So, you know, software, of course, is absolutely critical, and, you know, in a later time, I suppose that you'll hear more about this. So I guess I just want to close now in saying, like, you know, we in the industry, I think many of you have lots of experience in the industry. We've talked for a long time how computing is going to become, you know, very pervasive, and how the world is going to be smart and connected. What's really exciting is it's really happening now, right? It's already happening today, but it's going to grow, and the level of pervasiveness is going to be incredible. And, you know, I really can't think of a more exciting time to be in technology. I think this is sort of like a second golden age again, because, you know, it's not about getting 50% more. It's about getting 100x more in performance and capability and bandwidth, and that really is pushing innovation, right? And it really is because it's pervasive, and it's in embedded systems as well as traditional computing as well as entertainment. You know, I can't think of a more meaningful thing to be involved with, right? And I'm sure everyone would agree with this, is that technology is already touching everyone's lives on a daily basis. And that's one of the, you know, the bad thing about the supply constraint that we just emerged from is that, you know, everybody, not just we in technology, but every layperson understands now that semiconductors impacts their lives. And where things are going in the future, which I just walked you through in a very brief way, it's going to be even more so. And I think, you know, there are other social imperatives, like, as I said, is doing that in a sustainable way. And even more specific to the audience here, you know, AMD India, 6,000 R&D team strong, you know, yes. And still growing. India is, and I'm sure all the other, you know, large companies here present today feel the same way. we wouldn't be where we are today without the India team, and certainly the Hyderabad team here. Our teams are involved in every facet of what I talked about: silicon, technology, software, applications, IP, validation, right, security. You know, it's truly phenomenal. So, you know, and we're also engaged with academia and research and education. And, you know, not only is there a tremendous talent pool, and, you know, many other distinguished speakers talked about the entrepreneurial spirit and the focus of the government of really focusing on this area of technology. But, you know, I would say also personally that I think, you know, our teams are not only brilliant engineers and very motivated, but they really value teamwork, and that's a core cultural value for us. And they really want to do something innovative and disruptive to add value to our customers, to society at large. So again, it's the most exciting time, I think, to be in the industry. I mean, all of you here, that we participate together. And India is a crucial, and Hyderabad in particular, is a crucial part of making that future happen sooner and faster. So thank you very much.
Thank you, Victor. Kindly, I'd request you to please stay back. Thank you for taking us through the various hardware architectures and the software ecosystem stack. May I now request Kalpesh from Qualcomm, Senior Director of Engineering Qualcomm and Organizing Committee, to please bring out a memento to Victor Payne.
Thank you, I do, yes.
Our next keynote speaker, Mr. Asaf Tibol, is a passionate engineer, entrepreneur, and VP of Technology at Qualcomm. He leads 4G, 5G infrastructure modem design and architecture and heads multiple research projects and advancement of 5G and 6G technologies. In 2006, Mr. Asaf founded Design Art Networks, which developed 4G system-on-chip small cell-based station modem and served as a CTO and founder. Mr. Asaf holds over 200 patents in 4G and 5G wireless communication, signal processing, hardware architecture, and compute. Ladies and gentlemen, please welcome Mr. Asaf, and let's hear from him on 5G opportunities, challenges, and path to 6G.
Thank you. Thank you very much. First, I want to say that the Victor presentation was super impressive, and I cannot just fully agree with everything that you have said. It's really perfectly said. And I think that I'm going to tackle it from a different direction. But first, thank you very much for hosting me here, and this is a great honor to be here. And this is really impressive what's happening here in India. Qualcomm India is like already more than 7,000 people, which is just a big wow, okay? So thank you very much. Okay, so talking about communication. So Victor mentioned communication quite a few times, and I want to expand on that. This will be all about 5G. But before we talk about 5G, we need to look and glance quickly about the history of the wireless communication. So wireless communication was like every 10 years, we have a big leap on big Gs that we swap between them. The first communication technology was the first G, 1G, which was analog communication, moved to 2G, which was like moving from analog to digital to enable them efficient communication over billions of peoples. Then we moved to data communication with 3G, and then the real revolution happened with the movement to 4G, together with the smartphone, which is pretty much a computer on every one pocket. And now when you look on 5G, we are not anymore talking about only connecting people. We are talking about connecting everything. We are talking about connecting cars, and I'm going to talk about CV2X, which is wireless car-to-car communications. We are going to talk about connecting robots. Of course, broadband communication is there, and all those now new devices are intelligent by nature. So we are talking about connected intelligent edge, which we are going to expand about that quite a bit. Now, if you look on just a quick observation where we are today with 5G, so 5G is accelerating actually 2 times faster than 4G. So what we have today is 2 years faster than what we had in 4G in terms of the deployment and the wireless communication connections that we have over the air. And it's not anymore only mobile communication. We do have for only mobile communication for purely mobile broadband communication aspects. But also we do have that also for car-to-car communication, fixed wireless communication, actually, which is becoming more and more significant for India. If you look about replacing fibers with wireless communication, so 5G will going to address that with huge amount of capacity on a millimeter wave band, and I'm going to talk about that. So it's not anymore just a single device, it's a plethora of devices that I'm going to expand on it. This slide is actually very interesting because I think it is connected also to what Victor said in his presentations. So the hungry for data is always growing, and is growing very, very fast. If you look on the history of what happened in the world of communication from 2010 to 2021, this is what happened. A 100x growth, both in demand and also supply of communication over the air. And in order to enable that, we as a world and also as a Qualcomm, we developed a 4G technology, we evolved it to 5G,